Our topic for today is measurement of temperature. I hope you will enjoy this lesson. But before we begin the lesson, let's take a look at our objectives. By the end of this lesson, you should be able to state the types of thermometric properties that respond linearly to changes in temperature. Describe the types of scales used in measuring temperature. Describe the different types of thermometers used for measuring temperature and the type of scales used by these thermometers. State the advantages and disadvantages of alcohol and mercury as thermometric liquids. We begin our lesson with a measurement of temperature. Temperature is a measure of heat energy. And you looked at heat energy in your previous lessons, so I hope you have a knowledge about it. There are several ways to determine temperature. One way is by just using your senses. Objects with more energy will be warm or hot to touch. Things with less energy will be cool or cold to touch. So for instance, if you touch a glass with cold water, you feel the coolness with your hand, or if you touch a glass with hot water, you feel the hotness with your hand. Let us continue our lesson with thermometers. The accurate measurement of temperature requires the careful use of a thermometer. A thermometer is the instrument used to tell the temperature of a body. A thermometer is usually made up of a small hollow glass tube. At the bottom of the tube is a bulb, which holds a liquid such as alcohol or mercury. When there is an increase in heat, the liquid inside the bulb expands, pushing up into the tube. A decrease in heat lets the liquid contract, moving down the tube. A measuring scale is attached to the tube to give an accurate measurement of heat energy. We continue with temperature sensors. Another way of measuring heat is by using a sensor that detects heat. This changes into an electric signal and then is converted to a temperature readout. All thermometers make use of a change in some physical property of a substance with temperature. This physical property is called thermometric property. It is a physical property of a substance that varies uniformly with temperature. Some thermometric properties used in thermometers are: we have the change in volume of a liquid, the change in length of a solid, the change in pressure of a gas held at constant volume, the change in volume of a gas held at constant pressure, the change in electric resistance of a conductor, and the change in color of a very hot object. For a given substance, a temperature scale can be established based on any use of these properties. There are many different kinds of thermometers. For example, we have the liquid in glass thermometer, the resistance thermometer, the gas thermometer, the thermocouple, and the pyrometer. But in this lesson, I want us to focus on the liquid in glass thermometer. It is the commonest type of thermometer. This type of thermometer makes use of the expansion of liquids such as mercury or colored alcohol put in a bulb, which is joined to a capillary tube. The bulb is made of very thin glass, which allows liquid inside it to respond quickly to changes in the surrounding temperature. This makes small changes in the liquid volume noticeable. The liquid most often used in liquid glass thermometers are mercury and alcohol. Which liquid is chosen depends on how high or low the temperatures to be measured are likely to be. All thermometers have numbered scales marked on the stem of the glass. The scale must have a suitable zero mark and a suitable size for the temperature units. The size of a degree is settled by choosing two fixed points, temperatures that are the same the world over, and dividing the interval between them into equal parts or degrees. Let's now turn our attention to temperature scale. A temperature scale is a set of numbers used to read temperatures. To fix a temperature scale on a thermometer, we choose two easily obtainable temperatures, such as the temperatures of boiling water and freezing water, and give them numbers. These two temperatures are called the upper and lower fixed points of the temperature scale. We then divide the temperature range between the two first points into a number of equal parts called degrees. So you now know what the degree is. Two main scales are now in use, which is the Celsius or centigrade scale and the Kelvin scale. Let's now look at the Celsius temperature scale. One of the commonest scales used in making thermometers is the Celsius scale, named after Anders Celsius. It is sometimes called a centigrade scale. Centigrade means divide into 100 degrees. On the Celsius scale, the lower first point is the temperature of the pure melting ice known as the ice point. The ice point is fixed at 0 degrees Celsius. The upper first point is the temperature of a steam just above boiling water and is known as the steam point. The steam point is also fixed at 100 degrees Celsius, written as 100 superscript 0 C. So there are 100 degrees between the two fixed points on the Celsius scale. The distance between the two fixed points is called the fundamental interval. Let's now turn our attention to the Kelvin temperature or absolute scale. On the Celsius scale, pure water freezes at 0 degrees Celsius. However, temperatures below 0 degrees are obtainable. Experiments show that there is a limit to how cold things can get. Lord Kelvin showed that, theoretically, there is a lower limit to temperature, a temperature at which bodies have no heat left in them and at which all motion of the molecules ceases. This to the nearest whole number is negative 273 degrees Celsius. On the Kelvin scale, this is treated as negative 273 degrees Celsius, and it is known as absolute zero. The scale which has its zero at the absolute zero is called the absolute scale of Kelvin scale, named after Lord Kelvin. Who devised it? One division on the Kelvin scale is called a Kelvin and is divided exactly equal to one division or degree on the Celsius scale. It follows that there are 100 kelvins between the ice point and steam point of water. As the scale divisions on the two scales are equal, 1 Kelvin is equal to 1 degree Celsius. On this scale, the melting point of ice is 273 degrees Celsius and the normal boiling point of water is 373 degrees Celsius. As far as scientists know, nothing in the universe can get 0 degrees Kelvin. So please take note of that. Let's now turn our attention to the relationship between Celsius and Kelvin temperature. The absolute temperature, big T, corresponding to a temperature of small t degrees Celsius is given by big T is equal to 273 plus small t, where big T is expressed in Kelvin. Let's see an example. Convert 500 degrees Celsius into Kelvin scale. Let's see how the question can be solved. Big T is equal to 273 plus small t, and in the question, small t was given as 500 degrees Celsius. Therefore, big T will be equal to 273 plus 500, which will give us 773 Kelvin. I hope you also got it right. Let's see our second question. Convert negative 273 Kelvin into degrees Celsius. And you know that big T is equal to 273 plus small t, and the small t represents the degree Celsius. Therefore, negative 273, which is big T and was given in the question, will be equal to 273 plus t, which is small t. Therefore, small t will give us negative 273 minus 273, and this will in turn give us negative 546 degrees Celsius. I hope you got this answer right. Very good. Let's continue. We are still discussing the measurement of temperature, and at this point, I want us to take a look at the ice point. The ice point or the lower fixed point may be determined by putting the thermometer in a funnel of crushed ice as shown on your screen. The level of the mercury on the scale is marked when conditions have become steady. No correction need be made for atmospheric pressure. A change of 1 centimeter in the barometer changes the melting point of ice by only 0.0001 degrees Celsius. Let's now turn our attention to the steam point. The upper phase point may be determined by passing a current of steam around the thermometer in a hypsometer. Readings of the thermometer are taken over a period of 2 or 3 minutes to check that the reading is steady. The level of the mercury on the scale is marked when conditions have become steady. If in this experiment the thermometer does not read exactly 100 degrees Celsius, it may not necessarily be faulty. The atmospheric pressure may not be exactly 76 centimeters of mercury. A barometer reading should be taken and a correction applied. The temperature of boiling water depends on the dissolved impurities, whereas the temperature of the steam is independent of impurities. For this reason, the bulb is well placed above the water so that it will be heated by the steam rather than the boiling water. When the mercury level is steady, it is marked. My dear students, let's now take a look at the clinical thermometer. The clinical thermometer or doctor's thermometer is a special form of thermometer used for determining the temperature of the human body. And I believe those of you who normally go to the hospital, the doctors normally use the clinical thermometer to check your temperature. So I hope most of you have seen some before. Since it records temperatures only a few degrees above and below the normal body temperature, it has a short stem and is graduated over a range of 35 degrees Celsius to 43 degrees Celsius. The main feature of this thermometer is the kink or constriction in the tube near the bulb. The thermometer is normally placed beneath the patient's tongue or armpit and is left there for about 2 minutes to ensure that it fully acquires the body temperature. The mercury in expanding forces its way through the constriction to reach the maximum position. When the thermometer is removed from position, the mercury cools, contracts, and breaks at constriction, leaving a column of mercury in the capillary. To reset the thermometer, the isolated mercury column is shaken back towards the bulb. The bulb is small and its walls are thin, so that the thermometer is quick acting and reaches its maximum temperature after 30 to 60 seconds. The front of the stem is shaped as a cylindrical glass lens to magnify the thin mercury column. Clinical thermometers, also known as medical thermometers or doctor's thermometers, are used to take body temperatures in human and animals. Traditional thermometers use thermometric liquids such as alcohol and mercury to measure temperature in body cavities orally, that's through the mouth, rectally through the rectum, vaginally, that's through the vagina, or other axillary points such as the underarm, that's beneath your arm, your armpit. Many newer thermometers use infrared radiation to record temperature at alternative points such as the eardrum or tympanic membrane or forehead. Now let's see how the digital thermometer works. It contains a temperature sensor called thermistor. It is sensitive to electric resistor. At low temperatures, a thermistor will not conduct electricity, but as its temperature rises, the thermistor state changes and it becomes more and more conductive. Thermistors used in digital fever thermometers undergo this change in conductivity or resistance at temperatures near 36 degrees Celsius. Finally, I want us to take a look at the advantages and disadvantages of mercury and alcohol as thermometric liquids. Mercury expands uniformly over a range of temperatures, but alcohol does not expand uniformly. Mercury is very expensive and poisonous, but alcohol is cheaper and safer to use than mercury. Mercury does not wet or stick to glass, but alcohol tends to wet or stick to glass. Mercury cannot be used below 39 degrees Celsius, which is its freezing temperature. Alcohol, in turn, cannot be used below 80 degrees Celsius, which is also its freezing temperature. Mercury can be used up to 375 degrees Celsius, which is its boiling point. And alcohol can also be used up to 78 degrees Celsius, which is the boiling temperature of the type of alcohol. And that's about it for today's lesson. Let us see what we've learned in this lesson. In this lesson, we learned about the different types of thermometric liquids used in the measurement of heat. We also learned about the different types of scales used in measuring heat. We described the various types of thermometers and how they are used. We also stated the advantages and disadvantages of alcohol and mercury as thermometric liquids. This brings us to the end of today's lesson. I hope it's been interesting, exciting and educative, and I hope you've learned a lot of new things. Until we meet again in our next lesson, continue to read widely and solve more questions on your own, since this will broaden your horizon. Thanks for your attention and have a good day.